Okay, now we're going back to proofs. We're going to learn to write two column proofs, prove two triangles congruent. We're going to take all the stuff we've been doing the last few days before the quiz on proving triangles congruent, just drawing them out, marking the sides, marking angles, and using our rules. What are those rules? SSS, side, 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 angle, 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 side, and HL. Remember a couple of rules we don't have? We do not have angle, 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 and we do not have SSA. Just a reminder. Now, we've been doing some proofs before, but we're going to go back to it. So we want to draw a picture and mark on the drawing wherever we can. We talked about that before. You know, whenever you see a line that's equal to itself, mark it. If you have parallel lines, mark the alternate interior angles and so forth. Always write down the given information. How can we use that? And do they share any sides or have any vertical angles? Mark those right away. Prove them congruent using one of the rules. So here we go. If this was not a proof, and it was just the other day, and we were told that C was the midpoint of BD, well, we would just go ahead and mark this right there. And then BCF, from B to C to F, means this angle, not necessarily 90, whether it looks like it or not, is equal to DCF. Well, of course, if they're both equal to each other and they form a straight line, we know they're 90, but we can mark it just like that. And of course, the other day we would say, well, this line is equal to itself because it is itself. Again, if I separate it out and just cut down that line, this line would match that line. So, without proofs, we would just go right now, oh, S, A, S. That's what we were doing the other day. And we're going to do the same thing, we just got to do it in a proof form now. So, C is, I want to abbreviate, midpoint of BD. And angle BCF is congruent to angle DCF. And that's given. Now, even though we know right now that they are congruent by SAS, we have to justify all the marks we just put on there. So, for example, we have to say that BC is congruent to DC. And that's the definition of midpoint. And then the middle line we marked, CF, is congruent to itself. We know that, and we know why. But we have to say reflexive property. And we can abbreviate. And now at this point, we can say the triangle BCF is congruent to a triangle DCF by SAS. If you need to pause, go ahead, otherwise moving on. Number 2, we're told that AT is congruent to MR, so we mark it. We're also told that these are parallel lines. As soon as we know that, we can say, hey, alternate interior angles. Alternate interior angles. And we also say this line is equal to itself. And you can see already that we have angle, side, angle. We know we can prove this. We just have to prove it. So, given AT is congruent to MR, and AT is parallel. Sometimes you see them standing straight up, sometimes you see them slanted. I usually slant mine. It's up to you. Again, that's our given. So, first off, you pick. We can say MT is congruent to itself, reflexive property. And And now we're going to attack the angles. We're going to say that CRT, angle CRT, is congruent to angle. Now be careful. I'm sorry, not CRT. I was looking at the wrong example on my paper. I apologize. Angle ATM is congruent. Now remember, we're starting up here at A. We're going down Highway 1 and coming down Highway 2. So we're going to start here at R, go down Highway 1, and go down Highway 2. So that's going to be triangle RMT, or angle RMT. To get this angle and this angle are congruent. And that's where we use our old favorite. If lines are parallel, alternate interior angles are congruent. And now I'm just going to do the flip, the ones with the 2 hash marks. And I'm going to say RTM. So the unmarked road, then down Highway 2. So angle RTM is congruent. Unmarked road. Sorry, not starting at M. Unmarked road going this way, my bad. So starting at A and Highway 2. So AMT. And again, you can do that because it's alternate interior angles. And now at this point, we can say that our triangles, AMT, is congruent to triangle RTA. Sorry, RTM. And we can say by ASA. Pause if you need to. Okay, again, let's approach it like we're not doing a proof. What will we mark? Well, it tells us the angle X and P are the same, so we mark that. It says MP is congruent to XM. And it probably should read MX to be precise, going in the same order. Starting at the center, going out to P, starting at the center, going out to X. Okay? So those are our 2 givens, those are our 2 marks. But don't forget, we also know vertical angles. We always want to mark those wherever possible. We don't know about O and L. We can only do something with that if we knew LP and XO were parallel, but we don't. But we have enough information right now, don't we? We have A, S, A. So let's do it. Reason. Again, angle X is congruent to angle P, and MP, not MR, I give up. Is congruent to MX, and those are both given. Now we're just going to mark what we marked. So we're going to do XMO, angle XMO, and you don't have to go in this order, is congruent to, now remember, we started at the 1 mark, so we're going to start down here. We went down Highway 1, so we're going to go up Highway 1. So that's going to be angle PML. Okay? PML. Now, how do we know that? Definition of vertical angles. Okay. So, we were given an angle on the outside, we were given the line, and we just proved the angle in the middle, the inside, the center. So now we can say that triangle XOM this is a typo up there because there is no triangle XML. That's an angle. So this should be XMO and PML. Just little reversal of letters. Sorry about that. So triangle XMO is congruent to triangle PML, and that's going to be by ASA. Example 4. We have the Star Trek pad upside down. So SPT, where is that? S to the P to the T, that's right here. Is equal to OPT, so that's right here. So those two angles are equal. I just made it look like one angle mark, so I should kind of separate them out. I tried to do that, but I didn't. There we go. Those are equal to each other. And then SP, PO, those are equal to each other. Now, that's the given information. We know that that is equal to itself. And if we were just doing this without a proof, we would just say S, A, S at this point. But now we're going to put it into a proof. And it's pretty simple because we were already given 2 of the 3 things we needed. We were given the angle in the middle, the included angle. SPT is congruent to angle OPT. And we're given that line segment SP is congruent to line segment PO. And really, we should, to keep things in the right order, it should be OP. So we're coming out from the S down to the P and out from the O down to the P. Just keep it the same. Order is important. So that is a given. The only thing we added was that TP was congruent to itself. And that's by the reflexive property. At this point, we have all the information we need to prove the triangle SPT is congruent to OPT. Triangle OPT. And that's by SAS. And example 5. We know that X and P are equal to each other. And M is the midpoint of XP. So these two are equal to each other. And we know these are vertical angles. What do we have? We got ASA. Already done. We just have to show it. No big deal. Reason. Again, angle X is congruent to angle P, and M is the midpoint of XP. Given. We were given 2/3 of the information, sort of, but we still need to prove more on that midpoint thing. So we need to say that XM is congruent, be careful with order, PM. And remember, the old trick, PLM is what we're trying to prove. So PM, XM, they should line up the same way. So we're going to say that those are congruent to each other because of the definition of a midpoint. Now, we truly have the second of our 3 pieces of information. And now we're just going to say angle XMO, I'm starting at the 1 arc mark down Highway 1, is congruent to angle, start at the 1 arc mark, P, travel on Highway 1 to L. And that is definition of vertical angles. Now we have all of our information to say that triangle XOM is congruent to triangle PLM by ASA. You can hit pause if you need to. And the last example, here we go. BZ is congruent to bx. xy is congruent to zy. And we know that by is congruent to itself. We've got everything we need. This is going to be easy, breezy, beautiful. Cover girl. bz is congruent to bx. And xy is congruent to zy. All given. The only extra thing we needed to do was to say that by is congruent to itself. Find the reflexive property. We've got everything we need. We have side, side, side. So the order they gave us was xyb is congruent to triangle zyb, and that's by s, s,